Welcome back to Stewart Science. On this episode, we're talking about a super important skill, finding a relationship from the data once we collect it. So you've asked your question, you've designed your experiment, you've collected all your data, you've found your averages, you have 8 points taken 3 times each at least. Now what? So I'm going to give you a couple assumptions here that if you have any of these assumptions wrong, you will get bad relationship. Your data won't mean a thing. First assumption is that your relationship exists. That when you did your data, there was a connection between the thing you changed, your independent or manipulated variable. There's a relationship between that and your dependent or your responding variable. If there isn't, if it's not correlated, you're just going to have points all over the place. The second thing is that when you took your data, you designed a good experiment. If you didn't design a good experiment, not going to get a good result. The third assumption is that when you collected your data, you had enough of it. You had 8 sample groups, taken 3 times each and averaged, and that you did a good job when you were taking your measurements. Now what is the question? So I have some sample data here. I think it's easier to explain with sample data than it is to just give you all the strategies. So on the left column, you see it says time, and there's some times. And then on the right column, it says temperature, and there's some temperatures there. So the experiment that we took data for in this case was seeing how temperature changes over time. In this case, time is our manipulated variable, and temperature is our responding variable. Now, the first thing to know is that the manipulated variable usually, almost always, goes on the x-axis. So across the bottom is where you put the one thing you changed. So in this case, that's time. So time goes on the x-axis. That leaves temperature to go on our y-axis. You also need to include a unit when you mark it, both in your data and in your table. The last thing, I didn't have to put this on there, is that you need a title up here as well. Should be a title of some kind. And this one would say time versus temperature, or temperature over time, something like that. Something real simple. Now, you have all these numbers, and what I've seen a lot of people do in the past, I'll give you a list of all the mistakes, is they start drawing bars. Okay. Bar graphs are useful, but only if the data is what we call categorical data. If you can't put a number to it, then use bar graphs. If you're measuring apples versus oranges versus pineapple, you're testing different fruits to see how much sugar they have or something like that. Fruit is your manipulated, that goes across the bottom. Sugar is your responding, that goes on the y-axis. And so you have different individual groups, and their bars would be different heights. If you have 2 numbers, which is what we have here, this is called quantitative data. It's a data set where both axes have numbers. You should use what's called an X-Y scatter. What that means is that instead of drawing bars, you draw points. That's an XY scatter. Now, I drew those points really nice. In reality, what they'll probably look like is that. They're not going to be super clean, usually, because you're going to have mistakes in how you've collected the data. You've probably done some mistake, both in your measurement, maybe even in how you do the trial. So there's going to be error. Error happens as long as we are thinking about it. But you can see a pretty straight line there in the relationship. And so what you want to do, don't use bars, use points. Plot them on a grid. And so I'm going to want to see down here some numbers across the bottom. Now, I don't want to show you my handwriting because it's garbage, but I'll go by fives across the bottom. So I go 5, 10, 15, 20, and you write those times in and keep going up. And then you go maybe by 20s up this side, 20, 40, 60, 80. I want to reiterate, it's super, super, super important that you keep the same scale. Every box should mean the same thing. Don't call your first box 5, and then your next box 20, and then your next box 50. That's not how counting works. We all learned how to count when we were in elementary school. Either go 1, 2, 3, 4. So every box is 1, or you can go 5, 10, 15, 20, or 2, 4, 6, 8. The pattern needs to be clear. Then plot your points, which I have plotted there. So a couple things here. I'm going to recap what we have so far. Manipulated variable goes on the X. Responding goes on the Y. Don't use bars unless it's categorical data, unless you don't have numbers. If you have numbers, plot your points. Make sure your scale along the side stays the same. If you start by 5s, keep going by 5s. If you start by 10s, keep going by 10s. Don't change what every box represents. I do want to say one more thing about this too. Make sure you don't start that first one at anything else besides 0. I want to see 0, 10, 20, 30, 40, 50. Don't skip a bunch of numbers. Don't go 0, 50, 60, 70, 80, 90. I want to see all your numbers. It's going to be really important when we go down the road and talk about slope and y-intercept. But right now we're just talking about how we set up a graph. The last step is to draw the magic relationship. I call it the line of best fit. Draw a line down the middle of all your data. That line is the relationship between your X and your Y axis, between your manipulated or independent variable and your responding. That's what all of this data collection and observation has been working toward, is to get you to this point where you have this magic line, and that line at that point becomes what all of your analysis is about. That's the most important thing. Once you get there, then you can start making statements about your data. So to recap, once everything's collected correctly, you have all your data, all your numbers, all your averages, put the manipulated or your independent variable on the x-axis, put your responding on the y, number your axes so that you can actually see a line that takes up a decent amount of space. Be consistent. Be the same with your scale. 5, 10, 15, 20, 2, 4, 6, 8. You can go by 4s, 4, 8, 12. You can go by 13s for all I care. 13, 26, 39. I don't care as long as it's the same for every box. You can't change what a box represents. Then plot your points. Don't use bars. And then draw a line down the middle of all your points. That's called the line of best fit. So what you're making here is an XY scatter with a line of best fit. Once we get that line of best fit, we can get a lot of information from that line. This is Mr. Stewart. As always, keep learning no matter what. Oh, little bonus for you. All these skills that we just talked about in this video, we're going to get a computer program that will do it all for us. Because as good as we are at drawing straight lines and plotting points, the computer is way better than us. And as good as we are at finding slope and y-intercept, again, the computer is way better than us. So this is all really good information, but we're going to get a computer program that will make our lives so much easier. Take care.